So in this installment, we're going to take a little bit deeper dive in the rate of change in momentum over time. So what we have is a cart. $10-kilogram cart from rest, so V0 equals 0. And then later it's going at 5.0 meters per second, same 10 kilograms, and that delta T is 2.0 seconds. Well, what is the change in momentum? Well, let's see. Delta P equals M delta V, which is mv minus V0. So the mass is 10. The final velocity is 5. The initial velocity was 0. So we have 50 kilogram meters per second. It's positive because they're positive direction and negative direction. So it's the increase or the changes in the positive direction. What is the rate of change in momentum? Well, delta P over delta T is 50 divided by 2.0. So it's 25 kilogram meters per second squared. All right, so now the second part of this, we have the same scenario. $10-kilogram, V0 equals 0. And now we have a delta T of 1.0 second. 10-kilogram. And it has a velocity of 5 meters per second. So our change in momentum is m delta V, which is mv minus V0. We have 10, final velocity of 5 minus initial. So, hey, our change in momentum is the same, 50 kilogram meters per second. The change in momenta are the same. Now, what about the rate of change in momentum? Delta P over delta T is 50 divided by 1, which is 50 kilogram meters per second squared. So this rate of change in momentum is twice the previous. Now, if you put yourself in the place of the person's doing this, we have a person that pushes this cart and accelerates it. This one does the same acceleration, but in half the time. They must push 2 times as hard to do it in 1 second. And that push is force. And again, the rate of change in momentum is force. Different forces, different rates of change in momentum. Force is the rate of change in momentum.